Hi everyone, my name is Nina, and for today's interactive presentation we will be performing the iodine clock reaction experiment. And so we're going to be looking at the vitamin C variant, where we will have two solutions and they're going to be classified as solution A and solution B until we get to the very end where we are going to combine them. So let's jump into what we're going to need for solution A. I had to jump ahead a couple of steps just for time purposes, but I'm going to go in and explain. So for one, you're going to need your vitamin C tablets, and what's recommended is using two 1000 vitamin C tablets. So I have 500 milligrams here, so I just crushed up 4 tablets in a paper towel by using the back of the spoon. They are pretty hard tablets, just an FYI. Secondly, we're going to need our iodine tincture. So here I have 2% and I have 30 mLs, so I hope that works. And then lastly, we're going to be using distilled water throughout this entire experiment. And so for solution B, we're going to need 0.4 grams of cornstarch. So here I've got my cornstarch and my spoon all prepped. And then we're going to need 150 mLs of hydrogen peroxide. And then lastly, like I said, distilled water, just so we're not interfering with anything. And so with solution A, I already did it. And so what I did was, after crushing up the vitamin C tablets, I poured them into a clear mason jar where I then added about 60 mLs of distilled water, mixed it up to the best that I could. However, due to what's in the vitamin C tablets, that stuff is insoluble in water, so the mixture wasn't fully dissolved. And so what I went on to do was, you can either use a coffee filter. I used a strainer with a paper towel and just popped it into my mason jar, and this is the turnout from that. So it did appear to be a lot more clear after filtering it, and then the residue actually goes to show. Oops. So moving into solution B, so I measured out about 0.4 grams, you can kind of approximate it. So I got about that much, and then I poured 315 milliliters of distilled water. So this is what that looks like. It's pretty cloudy. I mixed it for about 30 seconds and it wasn't getting any more clear. So what I did was I popped it on my stove, since I don't have a microwave, and I boiled the water, and it was a lot more clear. And so I then still filtered it because it wasn't as clear as I wanted it to be. And then I was happy with how clear it was. And I then poured the hydrogen peroxide. I poured 150 mLs of 3% hydrogen peroxide, mixing it. So this compared to this, what a difference. Yeah, so that was a big difference, which is great. So now what we're going to do, we're going to move back to solution A. So we're going to add the iodine tincture into this vitamin C water we have right here. So I'm going to pour all of it in here. So what we know about iodine is that it's dark, it's got pretty strong colored, but we'll see what happens when we add it to the vitamin C water. So here we can see clear-ish, got some vitamin C residue, just a little bit. I'm just gonna pop it in here. Whoa, that's pretty crazy. It started out when you were pouring it, it was dark, and then as soon as it hit the vitamin C water, it went exactly back to the color that it was. So that's pretty cool. I'm glad that that was a success. That totally worked. It literally looks the exact same. So that's pretty cool. So that's solution A. It turned back to its colorless solution, which is meant to happen. So that's great. Now I could see if it didn't turn back, that just might be not having enough vitamin C, but I clearly used the right amount, so that's great. So the color of the tincture is going to be due to the presence of the iodine. So when it's going to react with the vitamin C, it's then converted to the iodide, or known as the I-, which is colorless. So now to complete solution A, I'm going to add distilled water on top, just to top this off. So I'm going to fill this up. just for consistency reasons, we're gonna use the same size mason jar. Okay, so we got them A and B, solution A, solution B. Now that I topped off solution A, what we're gonna do is combine them. So solution A and B are now complete. So now, like I said, we're gonna mix solution A and B. And it might take a little bit, but what we're gonna do is, I have a clean mason jar right here, so I've got solution A right here. And I'm gonna take a decent amount right here, fill it up. So that's solution A, and then I'm gonna pour solution B into solution A. Decent amount. Still pretty warm. I'm gonna grab my spoon and I'm gonna mix it. So I heard this can take a couple of minutes, so while we're waiting for something to happen here, I'm gonna just chat a little bit about the experiment. So, when we combine equal parts of solution A and B, which is what I did, it's gonna then cause two reactions where these reactions are gonna compete with one another. And so the hydrogen peroxide from solution B is gonna wanna oxidize the I- ions back into the colored I2 ions. And the vitamin C is gonna wanna reduce it from I2 back to I-. So these two solutions are ultimately fighting each other. And so we can think of the winner as solution B due to the excess amount of hydrogen peroxide in comparison to vitamin C, in which the hydrogen peroxide is going to consume the vitamin C, resulting in the I2 to accumulate, and the I2 complex combines with the I- ion, which causes the triiodide complex that's going to combine to the starch that leaves us with, hopefully, a change in color. It's supposed to be a dark color. Oh my goodness, as soon as I picked it up, that's wild. That's so cool. Yay. Experiment success. So with all that, I'm not gonna lie, right when I saw the clear cup, I was like, oh man, what did I do wrong? But obviously, it all was a success. It all worked out. It's nice and dark. Solution 2 wins. Cheers, have fun. This was a pretty cool and messy, awesome experiment. Thanks for watching. Have a good one.